accommodates posters, 2 rooms for the various talks. So it's very nice to benefit from the support of Occitanie region. So it's my pleasure to welcome Philippe Hertel for this.
Merci Serge. Je peux le faire en français, hein? Je vais être assez rapide pour simplement en quelques secondes vous souhaiter la bienvenue dans cet endroit emblématique de l'économie régionale. La cité a été réhabilitée il y a quelques années maintenant par la région et on est ravis de vous accueillir pour ces 2 jours de travaux dans le cadre de l'Institut ANITI. Vous savez sans doute que la région Occitanie est une des premières régions à avoir adopté une stratégie spécifiquement dédiée à l'intelligence artificielle, particulièrement autour de l'axe qui porte sur l'IA de confiance. Donc depuis le début, on est évidemment très engagé pour supporter ANITI et l'ensemble des travaux que conduit l'Institut. On est également engagé aux côtés de l'État dans l'animation plus large de tout un tas de sujets qui font l'actualité, des sujets évidemment d'innovation et de recherche qui vont vous occuper ces 2 jours, mais aussi des sujets d'infrastructure pour le territoire, des sujets de formation pour le territoire, des sujets de développement économique et de diffusion des compétences IA dans l'économie régionale. Tout un tas d'enjeux qui mobilisent très fortement la région Occitanie. Et donc, à ce titre en particulier, on est bien sûr très heureux de vous accueillir ici. J'excuse Marc Sulman, le conseiller régional en charge du numérique, qui devait être là cet après-midi et qui n'a pas pu être parmi nous. Et je vous souhaite bien sûr d'excellents travaux pour ces 48 prochaines heures. Merci à tous.
Okay, so let's move to the introduction to these days. So I will make a brief introduction, and I'm sharing this introduction with the direction of ANITI. Direction of ANITI composed of Romary Credon, who is our Director of Operation, Corinne Joffre, who is our General Secretary, and Hélène Tapp, who is responsible for the education program of ANITI. And again, I'd like to start with some acknowledgements. So I would like to thank the ANR, French ANR, for its support on ANITI. So Philippe Chamichian, who is here to represent ANR. You see probably that ANITI is really working in the way it works because of the involvement of everybody here. Everybody is, of course, universities, engineering school, labs, and also our industrial partners. And it's all these ecosystems that contributes to the success of ANITI. So it's very important to have you on board, and thank you very much for this. Today, we also have the pleasure to welcome some members of our international jury. So the international jury helped us in the first phase of ANITI when we were trying to build up a program and find the people who would be in charge in this program. So I'm really happy to welcome here Thomas Heiter, Thomas Powell, and Philippe Touin, who are sitting here and who have been very helpful and who are still following us and helping us when we have critical issues, scientific critical issues to sort out. Thank you very much. This event is organized under the guidance of the scientific committee of ANITI, but there are 3 persons who were really dedicated to the task of making all this run very well. And Marjorie, Alain Moulet, Louise Travé, and Nathalie Berniard, who are in the room somewhere. So thank you very much to the 3 of you, because your experience, you have been running this for several years now, and your experience makes this even very smooth on my side, and thank you for that. And thank you to all of you for coming here. So we have people in this room, but you know that we have another room also, because we were more than 300 participants. We are more than 300 participants to these ANITI days. It's really a lot. It's 1/3 more than last year. So thank you for your interest in those days. And again, I like to say that in ANITI we are really the direction team and all our councils are really working for you. So we are definitely more and more committed to advance research in our area with connection all around the world. So now let's start with the true stuff, true AI stuff. List of partners and so ANITI, was at the beginning committed to trustworthy AI because we are connected with 3 application sectors for which artificial intelligence or powerful artificial intelligence is not enough. Because we are really in charge of transporting people, collaboration between human and robots, issues related to environment, and in this you need an AI that you can trust. And for that, our program is not only about getting piece of software that could compete with the major ones that everybody uses every day, but it's also to have tools that we understand, and every day we are trying to make progress in this direction. You see here some members, so they are big. We are very proud of having such a committee around us. And recently, in fact, probably last year, we tried to organize ANITI in terms of research program as well. Not only research project and research chairs, but also program in the same way as major agencies. They describe themselves with programs they want to tackle. And here you see in this picture, you see 7 programs. The 3 that are underlined here are already launched. So what is a program? It's a place where you have several teams of researchers interacting with industry partners to tackle difficult questions and of course find also funding to fund the future research. So it's something that we believe is very important. And in the middle of this chart, you have core AI. Here it's the mathematics, computer science, robotics that you need to run this system. So for the 3 that we have already launched, you see that there is an impressive list of industrial partners that are partnering with us in this. Now for the rest, I tried to give an overview of what we practically did last year. And it's difficult because I mentioned the figures, 300 people, 19 research chairs. So I asked them, all the chairs, to produce one single highlight, one event that they would like to present to you because they believe it's making an interesting progress. So it's far beyond the epsilon added to some quantities. It's really something which is a major improvement in their research. So I will just browse all these highlights. So there are numbers. So pardon me, I will sometimes be very quick, but you will have the references. And most of them will be developed in the dedicated session to come. So not all PI have given an highlight here because some of them, I see Jean-François in the first row, some of them will present their work in the dedicated session. So I saw, yes, Nicolas here. So ANITI started with the idea of combining symbolic AI and more trendy AI based on statistic machine learning. And we are continuing along this track. So we have indeed results where we work on symbolic AI. And also you will see some of them where we truly hybridize the two approaches. Let's start with the symbolic AI stuff. So it's a work produced by Leila Mgoud and her chair. So it's about counterfactual explanation. So in counterfactual explanation, you try to see a necessary condition for some result to hold. So the minimum argument that you need for some result to get, and she with her co-workers design a taxonomy of such counterfactual explanation, and design in fact a new one which is more compact, shorter, and less numerous than others. And this was published in an AMAS 26. Along the same line of more symbolic AI, and now tightly related to the idea of certification. What is minimum explanation is the minimum explanation that you need to get some results. So here we try to prove things. So it's not statistics, it's real logic. And we want to prove what's the minimum explanation for getting a result. And it's a very tough problem, very time consuming, and they managed to have a piece of software published in ICLR with an important speed up. Another piece of work, very interesting, is in statistical learning. We do a lot of data augmentation to make sure that our result is robust under some transformation, rotation, translation. But you can also make this approach not statistic but rigorous. And this is what is done on the right-hand side. Another topic which is important in ANITI is Lipschitz network. In fact, they are not completely Lipschitz networks, they are orthogonal networks. So they have strong properties which make them not only robust, but also which makes them also more explainable. And this is the work that is presented here, and the interesting extension here concern convolution networks. And in convolution networks, it's much harder to get this Lipschitz property, and this is a work that was accepted in ICML 25. Here it's a very nice picture of the Orion constellation on the left, produced and Olivier Bernet from IRAP is an expert of that. And here, when you look at those objects with modern instruments, you get a signal in multiple wavelengths. And how to combine these wavelengths? So you see on the middle of this, you see attempts to combine them with the different curves, and you see that, especially the last one on the bottom, there is not a very a high continuity between the different curves. So what you want is to stitch the different bits, and this is done with the techniques here of matrix completion. And this is the work of Cédric Févot and his co-worker, and it's part of this James Webb Space Telescope mission. Here it's so you see on the top it's S, Y, and C. So it's a synergy chair. A synergy chair is a very original chair that we have in our institute, where we combine people from different disciplines. So here, Jean-Michel Loubet, statistician, Jérôme Bolt, more on the optimization side, Jessica Hénard on legal aspects, and Alex Molling more on economy. And so they are working. So Jean-Michel, of course, is involved in the evaluation of AI. This work is about understanding bias in algorithms. So you have bias in the data, but maybe it's less known that it's important to see what is the added bias that comes from the algorithm. And due to this bias in the data, loss functions that are not appropriately designed may introduce a further bias. And this is what is here studied and understood, and that was published in EURIPS 2025. So this is a work I was involved in as well. So it's Fabrice Gamboa, in the chair of Fabrice Gamboa. It's an amazing work because it's done by a PhD student, and it's what we call a CIFRE grant. So a CIFRE grant is an industrial grant, and it's quite. It's already a good result to have 2 patents during a PhD. Let me first explain the topic. So the topic is you have cameras on board of a car, and you want to diagnose the quality of the road to know how the car will behave. And so with this PhD, 2 patents were produced. But what is probably more impressive is that there were also 4 research papers, one in NeurIPS and one in TLMR accepted. And they use the Fermat distance for a better outlier detection, and also a robust classification in which the intra-class distance is minimized and the inter-class is improved for a more robust classification. Something which is also a bit more familiar to my area is AI and simulation. So this is a work produced by ENTC. Now on the top is one of our international chair, Alena Kopanikakova. And so she works with her team on how can AI speed machine learning. And you see on the top left, you see 2 rotors with blades, and the one on the left is produced by a mechanic model, and the one just right is produced with AI. So you probably see that there is an agreement between the 2, and this agreement is confirmed by the curves of pressure that are on the top right, where you see a good agreement between the solid and the dotted line, and this is solid truth, and dotted line is what we get with AI. A topic a bit different on the bottom of the slide is when you run simulation. Of course, it's very when you have difficult simulation, meaning that the geometry of, for instance, here the engine is pretty complex. You would like to save computer time and to use AI to produce surrogates, but this is not enough quite often, because we are used to use parallel computers to simulate. And if you do parallel computing in simulation with AI, you get the black curves on the right. I don't know if this would work. Okay, so the black curves, and you see from left to right in these black curves that when you increase the number of processors, the performance decreases, in that the convergence occurs later. And with the techniques Alena developed on domain decomposition and preconditioners, she can accelerate, and you get the red curves on the left that are converging very quick. Oops, sorry. Am I right? I don't know if I went. Okay, I nearly missed one. What is happening? Okay, so this is a work between 2 chairs, Louis Travé and an industrial chair. So industrial supported by RTE. And so this chair is about outlier detection. So there is a mathematical object called the Christoffel function, which is defined by, which involves in its definition the measure that supports all the data points. And it turns out that this Christoffel function, when you look at the level curves of this Christoffel function, you can see what is inside and outside, and for some level curves, it really amounts to detecting outliers with very few parameters. And this was discovered and used by the ANITI team in Toulouse, and used by Louis. And still, when you go for large dimension, it's a tool that may be expensive, but they found a way to make it scalar, using on univariate Christoffel function, and work in very large dimension with the work on infinite dimensional Christoffel function. So this is about reinforcement learning. Here we work on the Ising model. So an Ising model is a model from statistical physics. that you can find in many places, meteorology, in many areas. And in reinforcement learning, you try to learn how to transition from one state to the other, for instance. And this is what is done here with a new policy gradient method, which is faster than the other. So on the left, on the bottom, you see the blue curve on the top and the orange on the bottom. And you want to transition to the state where the orange is on the top and the blue is on the bottom. So this corresponds to spins, for instance, that are changing sign. And you see that the strategy on the top, the algorithmic parameters chosen by the algorithm, they are able to transition in two phases. The first is the two curves get the same, and the second one is really the flip that you expect. This is one of the big chairs of our institute. It's a 3.3 so it's cobots with conversation, cognition, and perception. And in here you have a lot of expertise in language, robotics, vision, and what they did here is they tackled a very difficult problem, which is a visual perspective taking problem. So in this picture, you see the teddy bear, and the question, just looking at this picture, is whether the teddy bear sees the house, and probably yes, and whether he sees the cross, and it's probably not. And this is a very difficult question, and it turns out that even if there was a lot of progress in machine learning for image processing, this is still a very tough problem. So the team proposed a benchmark of those techniques, and on the bottom right you see the result of this benchmark, and when you see the VPT basic accuracy, you see that human are still the blue horizontal line is what human can do, and you see that it's still an area where humans are much better than machines. And in the same chair, there was also progress in LLMs. So we don't want in ANITI to build competitors for ChatGPT, but we want to understand what is behind and what are the limits. And here it's a work of Nicolas Ascher and colleagues. And here you see on the charts you see bars. So the dark blue and light blue. So you see here the performance that the method, which is based on a manipulation done on the model. So you remove some of the layers that are used at the inference time, and you see that with an appropriate choice, you can have results that are better than on the top you have Qwen, and on the bottom you have a Mistral AI. So it means that you can still improve over those basic models. So maybe now we move more in the direction of applications. So this is a work done in an industrial chair by Olivier Roustan and Jérôme Monnier. So here the idea is to predict the occurrence of a flood. Of course, we know, especially today, that it's an important phenomenon that can occur. So using a technique-based basis reduction method, they were able to produce a collection of such situation, and also to produce simulators to have samples of such extreme events. So you see on the bottom right, on the top, on the right is what they produce. On the left is actual data. And if you go to their poster, they will explain you why those two drawings are very close indeed, and why you can use the one on the right to better produce the floods events. This is a result obtained by a chair on remote sensing. So here you have two instruments with different resolutions, But the good point is that they observe the same thing. And is it possible to combine appropriately the these two instruments to get observations at the same high resolution for the two instruments? So our colleagues derived, here you see an architecture with which they can get those observations at a fine scale. And what is very important is that they produce also a tool such that you can access at any time and any place. You can have access to those maps. So it's very useful. This is our chair on robotics. And so what is important in robotics is to, when you want to have an autonomous robot, is to have a good world model. Which can be used then for the tools like reinforcement learning. And using a technique which is called Dreamer V4, the team was able to design, and this is what you see on the right, a good world model that can be used in turn to program robots. And I don't know if you can go to the picture on the bottom, but the robots is able to bring the box into the goal with such a policy. More technically, there is a question here of computing the gradient in the optimization method here, and they use the simplified world models that they have to fasten the computation of this policy. Okay, so this is the robots, and let's see if we can just have one goal, and then we move to the next. So I think this is going to happen. Okay, 1-0 for the robots, and then meteorology. You know that we have Météo France in Toulouse. And this is something that was produced for the first time in our area. We are able to produce, to have an AI model, which is based on graph neural networks. And you see on the top left and on the bottom left and bottom middle, you see two maps. One is generated with a mechanistic model, and the other one with an AI model. So you see that there is a very strong agreement. They are not exactly the same, but it's a very strong agreement. And you see on the right what forecasters use to issue their bulletin. So you see that this information obtained in the middle can be used to produce this forecast. I think this is the last one. So the last one is related to again an industrial chair led by Sylvie Thiebaud. And we worked on a problem which is the problem of taking care of what Beluga delivers. And here we need an organization to dispatch all these objects that are brought by the Beluga. So it's a very difficult decision-making problem. And in this chair, they combine for this decision-making, they combine tools from logic, but also heuristics that are coming from AI. They try to have, to get decisions that are explainable. It's very important. And what is something that we are very proud of is that we can really give figures. So thanks to this decision making that they propose, we are able, or Airbus will be able to save tons of CO2 and even increase the speed of the deliveries. Okay, so all this is, of course, little blocks that brings to value to our leadership. And you see here the connections that we have all around the world. You see some figures about papers and researchers that get various prizes, and I'm very proud of all this that we have done this year. Finally, let's move to the program of the 2 days. So we will first have the session of SHS by Jean-François and Jessica, and then a session on fundamentals of AI led by Edward Powells and Nicolas Ascher. What I would like you to notice is that most of the names here, they're not really from ANITI, ANITI being the chair that for which we give funding. It's people who are now in Toulouse and who are happy to share their knowledge with ANITI. And it's something I had already on my first slide. We believe that we should move to the next step in ANITI, which is being the Institute for Artificial Intelligence in Toulouse. Very modestly, in the sense that we want to take into account all the different actors, universities, schools, and of course industry, and really try to accelerate the production of results in AI. So I'm finished, and I thank you very much for listening to me. If you have questions, I'm happy to answer, but and we can also ask Jean-François and Jessica to come to the stage, maybe to prepare for the next session.